Hi, this is Algebra 1, Module 4, Lesson 5. May I have more, please? And this is to just kind of solidify what we've got going on with our equations. So we're back with Elvira, our wonderful cafeteria manager. She has to be careful with her spending and manage the cafeteria so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes all of her budgets. So to start with, Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. The milk supplier charges 35 cents per carton. So let's go ahead and note that. 35 cents per carton of milk, in addition to the delivery charge of $75. What is the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? So write and solve an inequality that models this situation. So we are going to Um, first, see if we can figure out what our inequality is. Well, if we have 35 cents per carton of milk, let's just go 0.35, and that's going to be times C. We'll do C for every carton, right? So for the first carton, it's 35 cents. For the second carton, it's 35 cents. That's our number that's repeating. And then it says, in addition to a delivery charge of $75. No matter how many cartons she gets, she's got to pay that 75. So that's kind of our truck shows up, they pay 75, then they're going to get so many cartons of milk at 35 cents each. So 35 cents is repeating, 75 is a one-time thing. And then it has to be a maximum of $500. So our inequality has to be something where this side cannot be more than 500. So what that means is it has to be less than or equal to, can I get that to type in there? Less than or equal to, how do I get that to go in? Um, the 500. So let's see, how do I get that to go? To start a new one. Okay, so 0.35 C plus 75 is less than or equal to 500. All right, there's our inequality. Let's get rid of this one. All right, so now we have to solve this. Go ahead and put that in a different color. All right, so I'm going to take this and, oh, it's gonna let me move it. It's not. All right, so when we're gonna solve it, we'll go ahead and come back in here. And next line, it's not gonna let me do it. Boy, being tricky today. All right. So my next line, I have to then get um, my C by itself. How many cartons can she get with these restrictions? So first I'm going to subtract 75 from both sides. And that's going to cancel this one. So I'm going to have 0.35C is less than or equal to 5. Oh, sorry. We have to subtract, don't we? 425. So that is 425. And so now I need to divide by 0.35. Do to one side, I have to do to the other side. Now, because this is less than 1, but bigger than 0, I'm going to get a number bigger than 425. And so what I end up getting is 1,214.29, which means If you're talking in terms of cartons, I'm not going to get a partial carton. So we can't go over 1,214 cartons, equal or less than. So describe in words the quantities that would work in this situation. All right. So Myra can buy um, up to 1,214 cartons of milk and still stay in her budget of $500. So, and then the last one is write your answer using appropriate notation. So let's go ahead and write it in both notations. We're going to start with interval. So if I were to do this in interval notation, you can't have negative numbers of milk, right? So we'd have to start with 0. But then we could go all the way up to 1,214 inclusive. So that's set notation, or sorry, interval notation. Set notation, we'll put over here, and that would be the brackets, and we have to define our variable. So C would be C would be 0 is, we could have 0, so that would be a less than or equal to. C, which has to be less than or equal to 1,214. So that would be our set notation on here. So interval and set. Either one of them, because we're doing all real numbers, works. All right, next. Students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.2. Let me start making notations here. Let's do this one in green. Students eat about 2.25 gallons of ranch each day. That's a lot of ranch. Elvira started the school year with 130 gallons of ranch dressing. She needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. For how many days will her ranch dressing supply last before she needs to reorder? Okay, so there's a lot of information in there. Well, let's do our typical equation. We would say she starts with 130. 130 gallons is what she starts with, right? And then they're eating, so we're taking away 2.25 gallons each day. Now the question is how many days? So the first day they lose 2.25 gallons. The second day they lose 2.25 gallons. So my D will go with the 2.25. That's what's repeating over and over. And now I want this to actually stay above 20, right? It's at least 20. So if it gets below 20, that's when I have a problem. So this means it would be a greater than or equal to 20 when we're doing it. So questions for this, if it has to be at least, we want to make sure it's bigger than. All right, now we need to solve it. So let's go ahead and do this in our green. So I want to get things away from the D first. So I'm going to subtract the 130 minus 130. That cancels. So I'm left with negative 2.25D greater than or equal to 20 minus 130 would be a negative 110. And from here, I need to divide by negative 2.25 on both sides. Now remember, when we divide by a negative, what has to happen to the symbol? We're going to have to flip it. So when I come over here, I'm going to have D has to be less than or equal to, and when I divide that out, I have 48.89 days, which again, if I'm going to be reasonable, D has to be less than or equal to this. So really 48 days. Every 48 days of school, she's going to have to reorder ranch. So describe in words the quantities that will work in this situation. So now let's put some words to this. So Elvira will need to reorder every 48 days, and she can't have fewer than 0 to keep at least 20 gallons. All right. And then write our answer both in interval and in set notation. So interval notation would be 0, because she could order at 0 days. But then she needs to make sure she orders by 48 days. So we'll just have 0, comma, 48. But for set notation, let's make that a little higher here. All right, so set notation, we do our little brackets and define our variable. We have a D, and then our interval would be 0 is less than or equal to our days, which has to be less than or equal to 48, because we don't want to go over that time period. All right. We have two brackets going on here. All right. Messing up my interval notation. Okay. So let's keep going. The prices on many of the cafeteria foods change during the year. Elvira finds that she has ordered veggie burgers 4 times and paid, let's see, we'll go back to blue on this one, and paid these different amounts, $78, $72, $87, and $90 on the orders. To stay within her budget, Elvira needs to be sure that the average order of veggie burgers is not more than 82, not more than $82. How much can she spend on the 5th order to keep the average order within her budget? Okay, so now we have to think about averages. So in this case, we have averages is adding up everything you have and then dividing by however many you have. So we need to take 78 plus, should do this in black. Okay, so let's move that up just a little. Okay, 78 was the first order, plus her second order, which is 72, plus third order, which is 87, plus 90, plus she's going to have a 5th order. So we'll just do F for 5th order. And then all that needs to be in parentheses, because once we do that, we need to divide by 5, right? Because that's what average is. We add everything up and then we divide by 1, 2, 3, 4, 5 things. And then she said, has to keep not more than, which means this has to be less than $82. Okay, so now we need to solve this. Well, first I'm going to simplify this top part. 78 plus 72 plus 87 plus 90 is, yeah, 78 plus 72 plus 87 plus 90 is 328. So we have 328 plus f divided by 5 is less than or equal to 82. And now to get rid of my divide by 5, I need to times both sides by 5. That leaves me with 328, 328. Let me double check my typing here. 78 plus 72 plus 87 plus 90. Oh, 327. Thought that number seemed off. 327 plus f is less than or equal to, and 82 times 5 is 410. And so now it's a plus 327, so I can subtract 327, and those cancel, leaving my f. Don't need to flip the sign because I'm staying within, I'm keeping everything with not dividing or multiplying. 327 is 83. Less than or equal to 83. So this fifth order has to be at least $83. And that's exactly what we're going to put in this next part. Describe in words. Elvira needs to make sure the fifth order is $83 or less. That will keep the average 82 or less. All right. Write our answers in interval and set notation. So she could pay 0, right? Oh, could it be less than 0? Actually, she could technically get a refund on some of her stuff, which means she could get a negative. So if we're going to say she could get refunds on her order, then we would have to have the negative infinity in there. We'll go ahead and do that just so we have that example. So bracket, we're going to say negative infinity to 83. So she could, why it's doing that, 83. Okay, there we go. So saying she could get a refund. Otherwise, you would just say it's 0 to 83 like we've done before. But let's stay consistent that we're going to say she could get money back, so it could be less than 0. So then our set notation would be f is our variable, the capital F. And so f is less than or equal to 83. This way we have the example of kind of both kinds. If we would have had a infinity in there, or why it's doing that to me. Okay. Next, Elvira can purchase ready-made pizzas for $14.50 each. Let's go ahead and mark that on here. $14.50 each. If she makes them in the cafeteria, she can spend $44.20 on ingredients and $6.25 per pizza on labor. For how many pizzas is it cheaper for the cafeteria to make the pizzas themselves rather than buy the ready-made? So let's start with what they can do themselves. So they can make Um, 44.20 for ingredients plus 6.25 per pizza. So I'm just going to make every pizza, that's the one that's repeating per pizza. And for it to be economical for them to make it themselves, it has to be less than what it could cost for 14.50 per pizza. So here's where we end up with equation variable on both sides of the equation. So when they're making it, it costs 44.20 for ingredients and then 6.25 per pizza. Otherwise, they're paying 14.50 per pizza. And so we want to make sure that they're staying less than that 14.50 per pizza. So now let's go ahead and solve this. We need to, I'm going to change the color since all the others have been black. All right. So first I need to get all the p's on the same side. So I'm going to subtract 6.25 p from each side. And that will give me 44.20 is less than 8.25 p. And now to get it by itself, I need to divide by 8.25, divide by 8.25. So I'm going to flip this around just so I have my p first. So p has to be greater than 5.35. So what this means, if it has to be greater than this, they're not going to actually buy or make a partial pizza, right? So then we need to say 6. P has to be 6 or greater, the number of pizzas. So if we're going to put this into words, that means we want to know for what values is P cheaper than the ready-made. So really, it doesn't take very many pizzas to make it cheaper. For more than 6 pizzas, Elvira it would be cheaper for Elvira to make them herself. Make them herself. So she'll probably end up making all of her pizzas because I'm sure at a cafeteria she's going to make more than 6 pizzas. And write our answer both in set and interval notation. So we'll start with interval. Because p is greater than 6, 6 would actually, be our small number, and we would go to infinity because they can make an infinite amount of pizzas. And so for our set notation, click here, we would start with p has to be greater than 6. Why it's not liking my notations. Interesting. I don't know why it's putting all those extra lines in there, but you know what we're supposed to do with that. All right. I think we're almost two more on here. Okay, Elvira is comparing prices between 2 different suppliers of fresh lettuce. Val's Veggies, on blue this time. Val's Veggies charges $250 for delivery plus $150 per bag of lettuce. Sally's Salads charge 100 for delivery plus $4 per bag of lettuce. How many bags of lettuce must be purchased for vowels to be cheaper? So we want vowels to be cheaper. Okay, let's write and solve an equation. So we are going to start with vowels is $250 for delivery plus $1.50 per bag. So we'll use B. We want his to be cheaper. So for what values is his less than the other one, Sally's? Hers is 100 for delivery plus 4 per bag of lettuce. So she's cheaper to deliver, but her bags are more. So at what point is hers a better deal? All right, so let's look here. We need to get all the B's on one side and all the numbers on the other side. So I'm going to subtract 1.5B from both sides. And I'm also going to subtract 100 from both sides. I'm going to do this in one shot. 250 minus 100 is 150. Those two cancel is less than 100 minus 100 cancels. 4 minus 1.5 is 2.5b. From here, I need to divide by 2.5. And so I'm going to switch this just so I have my b first. B has to be greater than 150 divided by 2.5 is 60. So B needs to be bigger than 60. So what that means in terms of our understanding, Elvira has to buy more than 60 bags of lettuce for vowels to be cheaper. Okay, interval and set notation. Let's pull the blue out over here. So interval has to be more than 60. So 60 is our low value. And we're going to infinity for that. Set notation. I'm actually going to do this one with my text box. So set notation, our variable is b. B has to be greater than 60 for that to work. All right, last one. Each student that buys school lunch pays to this $2.75. The cafeteria typically brings in between $1,168.75 and $1,438.25. How many students does the cafeteria usually serve? So this one's a little bit different in how we set this up. We know the low amount that they serve is $1,168.75. We know that, turn this one green. Let's try this again. Okay, so 875. So that's the low amount they bring in. The student value has to be between this number, 2.75s, and the high number, 1438.25. So this one's an inequality with two symbols going on in here. So now we need to solve it for S. Well, notice that I need to divide out that 275. So what I do here, divide by 275, I have to do on every side. So I'm actually going to divide it twice on here. So 1,168.75 divided by 2.75 is actually 425. That has to be less than students. And if I divide out the 1438.25 divided by 275, I get 523. And so in words, when we're describing this, oh, that clicked on there. So describing this then is on a typical day between 425 and 523 are served. So somewhere in there is where she serves. Okay, interval notation and set notation. So interval, we are between. Notice how it's not an equals this time. So we will have, oh, I hit the wrong button. Okay, so 425, comma, 523, right? Because it's not equal to either of those, but it's between those two. And then for set notation, we're going to have our variable s, and 425 is going to be less than s, which is also less than 523. And then we close our brackets. So there's different ways on doing all of these. You might have the between, where you have to do both sides. You might have two equations that you're comparing to each other. It might be that you have variables on both sides, depending on what it is. And it might be more of an average, or our original, where we kind of just have a set fee and a repeating fee that we're trying to decide if it's greater than or less than. Thanks for joining us, and we'll see you next time.